Today we're going to talk about our WSN, our WSN802G. And this is a Wi-Fi module. It supports 1 to 11 megabit RF data rates. It's a 10 milliwatt module, and we call it B and G, which it is, but it will also compatible with N networks as well. So it will work with those access points. The key thing about this is that it can sleep. And the way it sleeps is it sleeps, but it sends very small messages, very similar to our heartbeats on some of our other modules, to keep the association with the access point active. So that means that when it wants to wake up and send data, it doesn't have to go through a 1 or 2 second reassociation. It simply wakes up, sends data, and then goes back to sleep. And the result of that is you get years on battery life. So it has the same auto reporting that we talked about with our other modules, the same type of sleep in terms of timer, interrupt, analog value. And it has serial to Wi-Fi capability if you want to use the UART or the SPI. And when you're doing the serial through the UART, it's unformatted serial to Wi-Fi. There are a number of people out there with modules, and they say, yes, we do serial to Wi-Fi. But when you get into it, it's a formatted. So you have to change the format of your data to take advantage of their serial to Wi-Fi. When you're using our UART, whatever your application data is, that's all you need. You don't have to add any headers or checksums or anything else to it. It's unformatted serial to Wi-Fi, which is really, we have a number of people that when we tell them that, they go, really, boy, that's great. That's a key feature because they'll have a legacy device that they want to attach Wi-Fi functionality to, and so they basically, unplug the cable, plug in this module where that cable was connected, obviously in an embedded manner, and they're finished. That's all they've got to do. Years on battery life, again, because of the very slow sleep current, the fact that it doesn't have to reassociate every time it wakes up, but it does have an always-on mode. So you don't have to use it as a sleeping mode, sleeping node. You can use it always on. And in the always-on mode, we have enterprise security. And so very few people have enterprise security in these modules. And this is the enterprise security that does, and I forget all the acronyms, but it does the certificate, and it does the supplicant, and it does the PEEP, and all the vegetable, the alphabet soup that you get into. So if people want to put something on, enterprise network where they've got all the security implemented, this is one of the few modules that will do it. Again, we talked about working on the B, G, and N networks, and the list price is $39, so it's very competitively priced there. So the value proposition here is it's a sleeping Wi-Fi, and it's also low power, which means that the peak current is such that you can run it off a AA alkaline. So the old notebooks that we used to have with the cards that would, the Wi-Fi cards that would draw so much current, this does not have that high peak current. So you're going to get I/O and years of battery life, and that allows you to take advantage of existing access points. So kind of the other half of the network is there. So you just have to worry about your nodes. You don't have to worry about a gateway or any other device to receive the data. You're going to take advantage of the existing access points. And you can have a wireless sensor node working on the same access point as someone's notebook computer. Okay, so it doesn't, there's no exclusivity required. It's just all Wi-Fi data going through there. So where it'll be used is where, like I say, the infrastructure already exists. You want battery operation, but you need Wi-Fi. Relatively high data rates required. It's 11 megabits. It doesn't try and do the higher 54 megabits and even higher of the N. But for the applications where you're going to be sleeping most of the time, waking up, sending brief amount of data, the 11 megabit is right where you want to go between the data rate and range. So let's see. So there's a question, I'm not sure there's any questions about concerns on the processor NOS. So one point I should mention here is that we have another product, a WLS, where you need drivers in the host processor. There really aren't any drivers here that are required. If we go back and look at this serial to Wi-Fi, that says you just send data to it. That's all you got to do. It's going to automatically join. You can configure it. You can configure it over the air. You can configure it through the serial port if you want to, but you don't really need the driver. So we don't worry about what the host processor is, because in many cases, let me back up here again, in many cases this is all the intelligence that's there. So we did a demo for a trade show where we took the module and we soldered a thermistor and a resistor directly to two pins in the module and had a wire hanging out for the antenna, and then two AA batteries. And that was a complete wireless temperature sensor. And we talked to it, communicated to it through a standard access point and in a standard notebook. So you don't need any other intelligence in these devices. But if you have it, that's fine. There's no driver needed. So you can use just a little 8-bit microcontroller to send data to this thing, because it's not going to have to handle all the Wi-Fi. All that is built into this module. All you got to do is send data through the serial port or wake it up through interrupts or whatever. So there is no concerns about a driver on this. There's a question about supporting USB, and we can support USB, but really what we do in that, and we do this on the development kit board, is like by using like a Maxim USB chip. So what we do is we take that input, really, and it's really at this end as a as a B device, a USB B device, kind of being a slave. Is what we're going to be getting is just the serial data. So at the other end, obviously you've got to worry about a driver for the USB. But at our end, what comes out of it really is just that we do the USB conversion. We've done it with FTDI, but there are others that you can use as well. So we're not going to put it on the module, and the reason we're not is because it increases size and cost. And if we had a customer that said, "Hey, I'm going to buy a boatload of these, but I need a version with the USB implemented on there," then we can certainly do that. But in terms of our standard product offering, this is being embedded, and so we're not seeing a universal demand for USB. But it's something we can add if we need it. Just finishing up, if you need serial to Wi-Fi or 802.11, and then again, if you want to avoid the coprocessor in sensing operations, and again that has both cost and battery implications by eliminating that that coprocessor. So where does this win? Well, it wins because it has the longest battery life, and it has more wireless sensor networking features in terms of the ability to wake up on timer, analog values, interrupts. It has the ability to, before it will wake up, it will activate one single line that will turn on, that can be used to turn on a sensor to allow it time to settle out before it takes a reading, before it wakes up the radio. So again, it saves power that way. No coprocessors needed. No programming is needed either for the module or for a legacy device that wants to communicate with it. And it has the enterprise security. Then again, we have this common footprint. But again, at the end of the day, it's value that we're delivering, both through the features, the price, and the technical support.